started here. So it's, XML files are supposed to be sort of self-documenting. The way I always look at this one is to say it's really a recipe for how you would recreate the information if you were if you were writing a program to do it in Java. So, okay, I have to make a new array list, and then I'm going to have to call array list add method on something that's a new student object, and that new student object I'm going to have to call set age with a value of 23, and then I'm going to have to call set first name with a value of Fred, etc. Okay, and so that's all that this thing is basically trying to describe, is how Java would recreate it, but it's obviously a fairly easy thing to read. Okay, so the rule for writing stuff out in XML is that this thing has to be officially a bean. It has to have some characteristics, because notice that there was nothing in the thing that said set first name. It just referred to the fields. And so they're assuming that there's, if you've got a field called last name, that there's a get last name and a set last name somewhere in the thing to make it work. That's the only way it can figure out how to do it. And the other trick that gets played is that a bean officially has to have a constructor that doesn't take any arguments, because what they're actually going to do is make a new empty student object to start with when they're reading the file back in, and then they're going to call setters for each one of the variables that they find in the file in order to set it. Okay, so that just becomes a requirement, and if you don't have something that satisfies that requirement, then it won't work. Now, with all of these things, both read object and write object, there's ways of working around problems if you have an exception to the rule. So if you don't have set and gets and you call them something else, there are tricks that you can play to add additional information to try to let read object and write object, for instance, know that you're special, and have it call routines, for instance, to do some of the things for you, et cetera, et cetera. But in general, that just makes your life really, really complicated. And if you can stick to that little pattern, then you get the reading and writing of files in different formats for free. Okay, so this thing has both serializable on it so that it can be read and written with read object and write object, and it qualifies as a bean, a separate idea, with the empty constructor and the getters and setters with the appropriate names for all of the fields. Okay. Notice that doesn't stop you from leaving public getters and setters and just putting them in anyway and never using them, and always using the routines that you want, like batter.tookStrike, right? So you could have a tookStrike and method that you use all the time, but you could have a set strike and a get strike, which you don't really want people to use, but they're there just to read and write the object out, or initialize the object. Okay, so there's a bunch of tricks that you can play, but there we go with the XML file. So now that we've got this XML file, the next trick is to go back to our driver and figure out how to read it in. And if this was my code for writing an XML student file, then the reading of the file is pretty much exactly the same thing. And someplace here I have copy of that thing, maybe with some minor modifications. So there's the idea. There's that Java beans thing. The decoder is the reverse of the process, and so it's just going to read the thing back in. How do you read it back in? It's just like read object, essentially. You make an empty list variable, and then you call the XML decoder on the input stream, which is basically whatever the file name happens to be. open the file, and then you just do one call to read object, which goes and does all the work of parsing the file and figuring out what's in it and making the student objects and making the list, filling the list, and what you get is just your list of students back again. Okay, so we'll call that thing with read XML student file, just to make sure the reverse process works, and we'll give it the XML file name. And in this case, you get a list back of students. That's the XML red version, is that thing. And so if you want, you can run a for each. So just write them all out again. So if you want to print out their last names, for instance, that should work to read them back in. Give it a try, and there's the rubble and the 2 Flintstones that are in there. Okay, so there's the easy transportable way to be able to look at stuff. This notice relies, there's no error checking in here, so if you go and edit the stuff by hand and somehow mess up the format, there's no DTD associated with this thing, and so it's just going to die a horrible death in some way, probably. So for the most part, these are hopefully used internally and not ever seen by, edited by real people, or you're using them to transport from one Java program to the other. Okay, so questions about that so far? Seems easy. What if I want to read in an XML file that somebody else has given me that contains frogs? The list of frogs. Any barriers to doing that?
You don't have a frog class?
Yeah, the obvious one is you don't have a frog class, and so you know, you're immediately stuck with, you know, this idea in Java that whenever you want to do something, it's got to be an object, and the only way you get an object is to write a class that has all of that data in it. And now you all of a sudden have to write a frog class that agrees exactly with what the kind of data is that's in the XML file, and hopefully rely on XML decoder to do the right thing for you, which I'm assuming will work, although I've never actually tried it. Okay, so it's not that easy to go the other direction. It works fairly well for, oh, I own this class to begin with, and I'm just trying to save my data or give it to somebody. It doesn't work very well in the other direction. Okay, so what would you be stuck with doing if you didn't want to make a frog class but wanted the information that was in the frog class?
Put it into an object and then make it a frog?
If you just want to look at some arbitrary XML file in Java or in any other programming language, there's sort of two general techniques for doing it. One of which you've been sort of kind of using in reverse. The sort of the two strategies, if somebody like gives me an XML file of something, don't know what, the first strategy is that you have the XML parsers that will just go through and basically scan looking for things for you. And you can think of it almost like being a sort of a Linux grep command. You go, you know, this is the thing I'm looking for in the file, only it's a little smarter. It'll give you whole chunks of the information that you're looking for, right? So you could actually go through the file and look at it by hand, just searching it as if it were a normal text file. You could use an XML parser, which is a little smarter about the file format, and be able to specify the chunks of things. Those types of things only usually go through the file from front to back. Okay, so you could do the equivalent of show me all of the first names and last names and weights of the frogs by going and basically scanning and parsing the file. What's the other sneaky technique that's used that you're actually doing in reverse in your PHP lab? From what I've seen. If I wanted to read a file, the other technique is for scanning is basically you have something that will go grab the entire file at once and suck it into memory and treat it as if it were a hierarchy or a tree of data that's now sort of live in memory, and then you can actually have commands that work more or less like change directory in Linux to go and drop down different levels of the tree, inspecting things as you go and saying, oh, okay, I've hit an element here that's got the right name on it, it's the kind of thing I want. Oh, okay, now let me go and grab the data from the element. Right? And so you guys are doing the same thing in reverse in PHP, where you're saying take this node and tack on this stuff to the node. Okay? It's essentially the same thing in reverse. Most of the time you do it reading stuff. Okay? So I was going to give you a quick chat about XML here. It's been around for a long time, and I'm going to speak about my biases as a non-XML person. I only see XML in a couple of places, and every time I've seen XML throughout the however long it's been around, I look at it and I go, oh, what a cool idea, I should really use this thing, it's got all this really powerful stuff you can do. And every time I start to use it and start to use the tools, I go, this is really complicated and ugly and frustrating, and it never gives me what I want. Okay? And a couple of years later, I'll go back and I'll go, gee, I wonder if the tools have improved, or I wonder if the way that you do things is improved. Is it still the rat's nest that it was? And I go, why, yes, it is. You have to be an expert on this in order to do anything useful with it. Okay? So I have yet to see XML in my daily life in a large thing used in something where I go, wow, this is really great, I understand it, and it's just the perfect tool, and why haven't I been using this before? Okay? That said, you actually find it in a couple of places very, very often. Okay? And so the first one I'll show you as a sample is, this is from Android. And if we go look in, just make it a little, well, or not, make it a little bigger here. Let's make it fill the screen. Every Android application that you build has an XML file that basically describes what the project is like that you're building and stuff about the application that you're building. And so here's a sample one from the Android developer site for just some app that they've got that they build. And oh, look at that. There's an XML file, and it's got some information, some sort of obvious information about, allow backup is true for whatever reason, and there's some theme that you can specify. The @ sign basically means the stuff is someplace else in another file. Okay, in this case, there's the name of the main program. So Android programs are Java programs essentially, but main could be in basically any one of the classes. And so this thing basically says, well, okay, here's where you can find the main and the kind of program it is for various reasons. And so this is all Android-y stuff that an Android guy would understand. But there's my start of Android application information, and there's my end stuff. And here's some description of some of the features that it uses. The features end up being things that when you download the thing from the App Store, it will go and say your phone does or doesn't have this facility available, so you can't use this app. So that, for instance, the latest ones have a step counter that's built in as a hardware sensor, so that you can actually use it to figure out people's activity. So they're getting into the physical activity monitoring type business for a lot of Android phones. Okay, so first place where you see XML files very, very often is in these sort of configuration files, because they serve the purpose of being exactly human readable text, where I can go and change some of the things in my configuration file and have it easily set. Okay? So config files are the sort of the first usage. And the second usage on a larger scale, I'll show you, is actually OpenOffice. So here's an OpenOffice spreadsheet where I've just put in, like first name, last name, first name and some marks, as if I were building a spreadsheet to keep track of marks. And I just happen to have this thing in just a separate file here, and it turns out that these OpenOffice documents or LibreOffice documents are zip files, so you can actually unzip them, and then you get a bunch of other stuff. And so there's basically the files in the thing. And some of these are like, there's a styles.xml file, right? Most of the stuff that we have from that file that we're interested in is actually in the content file, I think, if I remember right. So if we look in content.xml, it looks sort of like that. The reason it looks awful is because they don't actually put in line breaks anywhere. They just run it all together. So it's supposed to be human readable, but they're trying to save new lines. But you can see that there's some sort of style element across there that looks like it's got the XML-ish stuff. If we just actually look at this with a text editor, so we'll open that file wherever I hit it and take a look in the content of it. It complains that it's got line lengths that are too long, which is no surprise. But I'm just going to sort of cheat here, and I'm going to go down here and I'm going to grab whatever I can see here, and I'm just going to break it up a little bit. Just basically add some line breaks in so that we can see what's in it. I'm not necessarily hitting the right spots. I'm just sort of trying to go in between some of the close and open stuff. And at least you'll get the idea if I do enough of them. Okay. So what have we got there? There's some idea that, oh look, there's the text for the mark header line, the first line of the thing. I'm just really looking at the end of the file. There's some sort of table row. There's something that's a string. There's Fred that we had, and oh look, there's a floating point value that has a value of 3. Okay, and so very quickly you can sort of look through this thing and go, oh, okay, it's an XML document, and if I want, I could parse it in some format. Okay. There's actually a document on the OpenOffice website that goes through in great detail and tells you what the file format is and all of the sorts of stuff that you can do with it. But you don't necessarily need that in order to be able to, you know, sort of take a look at the document, just make a sample document and output the stuff. So for instance, if you look at if any of you have actually used the program, the web page that I have that goes out and gets your marks, okay? That thing, the program actually reads an OpenOffice spreadsheet. So in my office, I just have a spreadsheet that's got basically every, you know, a row for a student that consists of their, you know, the labs and the midterms and all of their marks on a row. And then at the top of the spreadsheet, I've got something that's defined as header information that every student should see. And all that happens when you go to the web page and enter your last name and your password is I just basically go grab the OpenOffice spreadsheet from the web server as an actual, have it crank up a Java program. The Java program goes through, grabs parses the OpenOffice spreadsheet, like unzips it, grabs the content file, grabs the header information that every student should see that's at the top of the file, and then goes and finds just your line of information and plops it in and makes an HTML document, not with a style sheet, actually done the hard way by making the individual HTML items, but produces the web page that you see. Okay? So on the big end of the scale, you will see some of the big people that have been using it for a long time, because this makes this format transportable and documented rather than having the sort of the traditional binary files that people have to go and inspect in the old days and try to figure out what the file format was. Now they quite often do it as text files. Okay? And it's not obvious that this thing is really just a zipped bunch of XML files, but really easy once you've seen it. By the way, Eclipse also has XML editors, so that's a good thing. So if you go to the Eclipse install new software thing under help, you can actually go and grab XML editors and use them to edit whatever you need to. Usually I find with XML, the XML editors are really annoying because you have to keep breaking open all of the individual parts as you're going down the tree, which makes it really, really annoying. So half the time, if it's only a small document, I end up just cheating and editing by hand. So for instance, the Android stuff has an XML editor built into it. It's really just Eclipse with some add-on features for building Android stuff. And when you go, they give you, they have the XML editor just built in, but every time I go to use it, even for one of those short little config files like I showed you, I end up being frustrated by having to crack open the stuff, and so eventually I just go back and do the normal text view and just fill in things that way, and it works just as well. Okay, so really typical either for big things or small things, and not much in between. Those are the only two uses in my life where I've ever seen them doing things with XML, but very handy when you need it. Okay, so questions about doing that from Java? Okay. Let's go see what else I had for today. There were a couple other little minor things I wanted to look at, if I can now remember what I was going to do. Where did I put it? Okay. The next thing I wanted to do was go back and look at the file class. And if we go look in the documentation for the file class, there's actually, this is one of them that has a surprising amount of documentation, relatively speaking. Okay. So if we want to use the file class to get information about a file, you can either do it as a string that's a path name, you can use a file type URL, etc. And let's just look at some of the methods. If you had to describe what this thing is used for, just looking at some of the names of things. It's a directory, it's a file, when was it modified, the length of the file. Go back to the command that I just used here. Okay, so the Linux ls command gives basically information about a file, size, length, who owns it, etc., etc. So the same thing applies to the file class in Java. Its only use is not to do anything with the guts of the files. It's basically to describe all of the metadata about the files. So there's length, there's tell me its name, tell me how I can get to the parent directory, etc.
So it's more a file browser than an actual file?
It has nothing to do with the internals of files. So yeah, you could use it to build a file browser, because it knows about, you can ask questions like, is this a directory? And if you know it's a directory, you know, okay, I need to do a change directory command to drop down a level to show what's in the rest of it. Okay. So let's just look at the file command. The only place where we've actually used it so far is to use it in the sense of a path name. So I made a string. I'm just trying to look at. So this was basically a path name, and if you look at how the files are opened, I don't know if that thing actually put it into a file object. File input stream ends up using the file class. I think we used it for some of the earlier stuff we did. It's lost on me whether we did, but it sort of doesn't matter at this point. So let's just give it a try. And because this thing is starting to get ugly, I'm just gonna go make a brand new driver program that's got less stuff in it. Give it a really silly name just to annoy you. So let's give something a try here. Current directory equals new file with a dot in it. So dot in Linux is the current directory. And notice that this is the old version. This is Java IO, so this one's been around for a while, I think since Java 1.0. And then we can do something like, let's just try current directory dot, look, we can read it, write it, delete it. We can see whether or not it exists. We can get some paths. Gee, I wonder what that one does. Oops. And an extra bracket there. And we have to just add a throws to make the silliness go away. So that's saying there might be a problem if I don't specify an actual decent name in there. And then we'll run it. And oh, look, so that gives the full path name for the current directory. Okay, so you can basically start to get all sorts of information. Oops.
It's a canonical path as opposed to just directed the path.
You can find the parent, so you can work your way back up the hierarchy. You can find out whether or not the thing is actually a directory. So if I've just given a path name there that ends with an actual name, and I don't know whether it's an actual directory or whether it's a simple file, there's an is directory, which in this case will return true. So you can find out if it's a file or a directory. If it's hidden, you can get information about last modified, length of the file, which doesn't apply to directories. And oh, here's one. You can get a list of all of the files that are in the directory. Well, that looks like fun. Let's give that a try. So this thing returns a file array. By the way, notice the fact that it returns an array is a pretty good indicator that it's been around for a long time, before ArrayList came into being, so from the very beginnings of Java 1.0. So there's an array of all of the files that were in the thing. We've said that you can actually run a for each on an array. So for this is file, a file in all files. Print a file dot equals yada yada yada. Scroll down a little bit. Oh, look, there's a get name. And there's all of the files that I have in that directory, and we can just go double check with the ls command. So there's my current directory, and oops, where am I? I guess I'm in a different place, aren't I? Oh, let's just do that then. Let's just change the path to, instead of dot, let's change it to, just to show you an actual path in there. Thank you, Eclipse. So here's /home/Daryl, just because it's easier for me to find that. Save it and run it. And there's all of the files that happen to be in my home directory, including all of the dot files, because the default is to show them all, and the ls command is actually hiding stuff for you by default. So there's all of the files. Okay. What if I wanted those files in sorted order, which would be sort of nice, instead of just in some arbitrary order that they were added to the current directory? How would you put them in sorted order?
You take the array and put it into ArrayList and call collections.sort.
Yeah, you could take the array and put it into an array list and call collections.sort. What's it going to sort the file class by?
Default.
The default sort. I wonder if the file class has a implements comparable. Oh, it's got a compare to. I wonder what the compare to. See if it actually shows up there. Oh darn. I don't think they necessarily put these in order. Oh, there's compare to. So they're compared, that's basically alphabetically. Oh, well, what the heck? Give it a try. Now, you want to use collections.sort on this thing, so there's a couple of ways that you could do it. One way is you could do this. You could say a list of file. Oops, I think this needs to be afterwards. List of files, sorted files. Is all files. You can try to do new array list. With all files in it. Give that a try. And it still says, we'll put file in there just to see if that helps us out. And it still says there's no constructor to do this. So for as much as arrays pretend to be like array lists, at least in terms of for eaches, they're not one-for-one interchangeable with each other, so you can't put something in there where it's expecting another array list to copy. Shortcut for that? There is a conversion utility. I talked about it way back when. Once there's arrays.asList that says treat that thing as if it was a list. So it's a sneaky little conversion utility. Just temporarily pretend it's a list long enough to get it dumped into the array, and then we could do collections.sort on the sorted list, and then we could oops, can't see what the
sorted files.
Sorted files. Thank you. And then we could print out sorted files here.
Bam.
There you go. So one of the reasons for showing you that was to remind you that, I mean, that, you know, this compare to and equals idea is actually really powerful, and it gets used a surprising amount for doing all sorts of silly things. And if you've got that ability, then all of a sudden it makes your life fairly easy. There's another way of doing this, by the way, which is that you actually don't need to do the conversion at all. What you can do is, instead of using collections.sort and then doing it, I'm just going to put this back to all files. That only works on things that are lists. It turns out that in the old days they had arrays.sort instead. So arrays was the class that was used when you had arrays before you had lists of things, and they came up with the collections library. And so that will sort an array based on, hopefully, compare to, and we run that and it still works. Okay, so that's a reminder that there are the old-fashioned ways of doing things still, and you have your choice of going and digging out the old-fashioned ways or doing the modern way. Okay, well, if they insist on giving me an array, let me dump it into a list that I know how to work with. And so you can actually get by with just the two conversion utilities, put everything into lists and not worry about the old style stuff. Suppose, just for fun, that there was no compare to, and I needed a comparator because I didn't know how it sorted, and so I wanted to ensure that it sorted by name, or I guess we could do it by, hey, it's got size. Suppose that I wanted to sort these files by size. Not that I'm printing out the size at the moment, but let's do plus something, and I wonder if it's got something that looks like size, a file dot total space is the total space on the disk, length is the length of the file, which may be the size. Delete, notify, wait, so it must be length. I'll just give it a try. What did it say for length? Length in file in bytes, so that should work. Okay, so if I want it sorted by length, then I can't use the default compare2, so I need a comparator to do it. Quite often you'll see people just say, well, okay, if I need a comparator, I'm going to just write one. And so you can play this game. A new comparator, if we do the import statement, requires that a comparator have a public int compare, and compare takes file A and file B, and we can return A dot length minus B dot length. Assuming I got that almost right. It's a new comparator only for file. And that's it's just upset because that needs to be converted to an int on a good day. Yeah, close enough. So files can be larger than 32 bits, which is why it's sort of upset there. So I'm just going to cheat since I'm working with small files here. It's probably not the best thing to do. But you quite often see people write comparators inline like that just because it's fairly quick and efficient, and I don't want another class to do it, so I'm just going to do that, and then we'll give that one a try. And there's the file sizes in addition to them. Directories typically always show up as 4K because that's the size that they're a fixed length file, so that's the size that they're made with to start, but there they all are now in file size order. Okay. So my intention here wasn't to do a lot of, sort of going through and showing you operating systems type stuff. It was just to show you that, hey, look, it's pretty easy to go use some of these things even without knowing a lot about them. You're now sophisticated enough to be able to go, oh, okay, let me go list the files and let me put them in order of something without a problem, so you can now write your own Linux file browser that works across systems. And with that, we're done.